What are the different adrenergic receptors? How do catecholamines exert their mechanism on these receptors? What are the most important characteristics or features of these adrenoceptors and how are they regulated? Well, to have this complete initial introductory adrenergic receptor overview, these and many more questions will be answered in the current conversations. No more thinking or talking, simply let's break into this. Welcome all to this Pharmacology Difficult podcast. I'm your host Dr. Radhika Vijay, MBBS MD Pharmacology, and this is the audio hub to get the best simplified basic tips, strategies, methods, and lots of ideas to learn better, understand better, and make your concepts crystal clear. If you really find and if there's a question hovering in your mind, is pharmacology difficult? Lend me your ears for a while and let in the magic of knowledge. Let's start with a bullet point list of some general and common characteristics about the adrenergic receptors. Well, the first point to know is that Ahlqvist, capital A-H-L-Q-U-I-S-T, Ahlqvist scientist in around 1940s, he classified the adrenergic receptors into alpha and beta. And what was the basis of these classification? Well, it was the potency of their agonist. As in the case of alpha, adrenaline was found to be highly potent, while in case of beta, isoprenaline brags this order. Now, this classification had its support with the antagonist discovery. The antagonist for the alpha receptors was phentolamine, while it was propranolol for the beta receptors. Second important point to know about these receptors is that all of them, they are G protein coupled receptors, and they have their second messengers like IP3 and capital DAG, that is diacylglycerol, and cyclic AMP, that is CAMP in the case of alpha receptors, while it's only cyclic AMP in the case of the beta receptors. And sometimes potassium and calcium channels, they are too playing their parts, as in the case of alpha and beta receptors respectively. Classification grew and the types of alpha and beta receptors, they were discovered, their basis of discovery being the specific organ action sites. Now, beta receptors, they were initially divided into beta 1 and beta 2, and later the beta 3 subtype was added in this list. Let's get to know their features. Beta 1 features are, they are found in the cardiac sites on the kidney juxtaglomerular cells. They have their agonist as dobutamine, and one of the antagonists, which is quite common, is atenolol. Let's get to know the beta 2 features. They are found in the respiratory tract, blood vessels, urinary tract, ophthalmic sites, uterus, gut, etc. The well-to-know agonists, they are salbutamol and terbutaline, while antagonists to know, they are alpha-methyl propranolol. Let's talk about the beta 3 features. They are found in fat tissues, adipocytes. They are also found in bladder, detrusor muscles. The best to know agonist is marabegron, that is a specific one. That was a general overview about the subtypes of the beta receptors. As far as the alpha receptor classification is concerned, they were classified based on their site of the presence, that is some kind of an anatomical location initially, but later on this basis of classification was their agonist and antagonists. So they were classified as alpha 1 and alpha 2. Let's get to know their features. Alpha 1 features. They were present postsynaptically on the effector sites. The action was found to be prominent on the smooth muscles, gut, glands. The agonists to know for these alpha 1 receptors are phenylephrine, and the prominent antagonist was found to be prazosin. Let's talk about the alpha 2 features. The site was presynaptic and also it was postsynaptic. They are present both presynaptically and postsynaptically. Actions were found to be on the nerve endings, brain, pancreas, platelets, blood vessels, etc. What are the agonists that are to account for? They are clonidine for these alpha 2 receptors, and antagonists to know they are yohimbine and Rauwolz-C. Later on, many modern techniques were adopted. One of the famous one was cloning that identifies 3 each subtypes of alpha 1 and alpha 2 receptors. For alpha 1 receptors, the subtypes they were alpha 1A, alpha 1B and alpha 1D, A, B, D. For the alpha 2 receptors, the 3 subtypes found were alpha 2A, alpha 2B and alpha 2C, A, B, C. So there's a difference of the last one, that is, it is alpha 1D in case of alpha 1 receptor subtypes, while it is alpha 2C in case of alpha 2 receptor subtypes. A and B are same in both. Let's get to know the catecholamine action. As far as the catecholamine action is concerned, adrenaline, yes, epinephrine that we also call it, it activates all the adrenoceptors, alpha, beta, all the receptors. While the case is quite different in case of norepinephrine or noradrenaline, because it primarily activates alpha 1, alpha 2, beta 1 and beta 3 receptors, while its weakest effect is found on the beta 2 receptors. I hope you'll note down this thing and remember it forever, because it's gonna help you in the understanding in further systemic pharmacological chapters. Now, coming over to our last portion of today's episode and let's have a chat about the receptor regulation. Now, many activities in the body and physiological as well as pathological processes, they have marked influence on the receptor number and action. I mean, their density, their efficacy. Let's get to know the details. The first process is up and down regulation. Upregulation occurs when antagonist occupies the receptor for a long duration of time. Then number of the receptor goes up. Their sensitivity or response also goes up. The mechanism is actually the externalization of the receptors on the membrane from the internal side of the cell. Now, this is not only affected by the various processes, but hormones too, they lead to the upregulations. And one of the prominent one is the thyroid hormone excess. It leads to upregulation of the beta 1 cardiac receptors and also its sensitivity, especially to catecholamines. And what the results can be observed? Well, increased in heart rate or tachycardia. That was all about the upregulation. On the contrary, downregulation occurs when the agonist occupies the receptor for a long duration of time. Then the receptor number goes down. And the mechanism involved is either endocytosis or internalization of the receptors. The best example I can give you is about the insulin receptors. There we can see very nicely the downregulation of the receptors. But sometimes both up and down regulation are observed, like in alpha and beta receptors, and both are G protein coupled receptors. Alpha and beta receptors, they express both types of upregulation and also the downregulation. That was the first process involved in the receptor regulation. Let's talk about the second process, that is desensitization. Now, what is desensitization? It's the prolonged activation of the receptor by the agonist. When agonist is actually continuously activating the receptor and occupying it, slowly the receptor response to the agonist goes down. And I'm sure you might have heard very nicely well-known terms in this particular context. They are development of tolerance, tachyphylaxis, which is actually another term for acute tolerance, the receptors turning out to be refractory, etc., etc. Now, this is a very quick phenomenon. Why I'm telling you this? Because as compared to the downregulation, it's very quick, while the downregulation is quite slow to develop. The best example I can give you here is the desensitization of the beta receptors by the beta adrenergic receptor kinase, which is also abbreviated as beta capital ARK. Now, what happens actually? The G protein coupling is lost. And to restore this coupling, the beta agonist has to be removed. And this process of desensitization is very, very common in the diseases and pathology like bronchial asthma. And now we're going to talk about the third process of the receptor regulation, that is supersensitivity. Well, what leads to supersensitivity? First, no agonist for a longer time. Yes, there is no agonist on the receptor for a longer time. The receptor is supersensitive now. Second point, denervation. Denervation supersensitivity also occurs. Third, the antagonist occupies the receptor for a longer time. Yes, all three types, no agonist, denervation, or antagonist for a longer time, can lead to supersensitivity of the receptor. And what is the mechanism involved? It's neither internalization nor externalization, nothing like that. It's actually the new receptor synthesis. Yes, new receptor synthesis occurs and they are expressed freely on the cell surface. And they are so sensitive to even petty and small amounts of the stimulus or the amounts of neurotransmitter, because they are juvenile new receptors. You can call it a kind of a heightened upregulation. And the best example I can give you here is, you might have heard about rebound hypertension. Yes, I know you might have heard about it. It's a common term. So rebound hypertension development after the sudden withdrawal of the clonidine. That's the supersensitivity phenomena. Now with these wonderful novel discussions, let's look forward to the Halloween season and holidays. It's a great reason to rejoice these days. These are filled of magical treats, wizardly, witchy, hocus-pocus tricks, and so much fun, especially for the kids. My heartiest seasons and holiday greetings. May these days be filled with moments of gratitude, fun, peace, joy, sweets, and a lot of goodies and decorations. Have a great time. For all the updates and latest episodes of my podcast, do visit www.ispharmacologydifficult.com, where you can also sign up for a free monthly e-newsletter of mine. It actually contains a lot of updates about medical sciences, drug information updates, and my podcast updates also. You can follow me on different social media handles like Twitter, Insta, Facebook, and LinkedIn. They all are with the same name as Pharmacology Difficult. If you're listening for the first time, do subscribe and follow whatever platform you are consuming this episode. Stay tuned. Do rate and review on iTunes, Apple Podcast. Stay safe, stay happy, stay enlightened. Thank you.